Swayam Prabha. Digital India. Educated India.
So, friends, today in our lecture we are covering the connect of industry 4.0 and product design. This is a course of operations and production management, and we are covering the unit 2, that is design of products, services and selection of processes. We are observing that in the last less than a decade, if we see that there is a lot of literature, lot of applications of industry 4.0 is coming in academics as well as in our real practice also. We are finding that several products and processes are influenced by these technologies. What is industry 4.0? This is the various technologies which are facilitating this industry 4.0 is, when we say industry 4.0 means there is first revolution, first industrial revolution, then there is second industrial revolution, then there was third industrial revolution, and the present one which we are witnessing now is the fourth one, and that is why it has been given industry 4.0. So, this is the fourth industrial revolution which is dictated by mostly with the help of technologies which are moving around electronics and computer science. The important technologies which are part and parcel of industry 4.0 are internet of things. The key word is thing. That means anything which you are using, whether I am using a pen or here projector or any such thing, it is connected. There is some digital twin, there is some chip which is attached to this, and the whatsoever I am doing, the way I am using, the information is going to the internet. The data is collected about this and about the environment also, and this information is going to the cloud, and then with the help of big data and data analytics, the data which is collected about the thing as well as its surrounding is analyzed, and some kind of improvement, some kind of prediction, some kind of feedback is given to the system. Third important technology which is part of the industry 4.0 is augmented reality. As a human being, as a processes, we can see something, but with the help of this technology we can improve, we can see something beyond what physically we can see. So, that is virtual representation of the real world, something of the real world which is not possible to see with the normal way. This technology helps in realizing that reality also in a virtual manner. Cyber security is another important technology which is required when everything we are feeding to the internet. So, we need that our data, our networks, our cloud should be secured, which should be safe. Then there are collaborative robots which are playing a big role in this. Several things can be achieved without the human interventions. So, with the help of robots, with the help of passengerless cars, etc., etc. So, that additive manufacturing, as I was talking in my previous session also, additive manufacturing is playing a big role in achieving the goals of industry 4.0. So, here with the help of additive manufacturing you can produce even a single unit in a most economical manner, and you can customize it also according to the requirements of the customer. So, various types of medical implants, etc., can be produced with the help of additive manufacturing. Then cloud computing, as we are saying that data is going to the cloud, and then the cloud computing, rather than computing, this is we call it network as a service or cloud as a service or software as a service can be applied. So, you need not to own such resources, only you can use it as a service. Artificial intelligence will play another very important role. With the help of artificial intelligence, we can do the grouping of the various requirements, we can develop the regression models by which we can do the predictive analysis, or we can do some kind of a clustering also with the help of artificial intelligence. The major role which it is going to come is in the form of forecasting the requirements of your products. Earlier we are doing the forecasting based on the lagging parameter based on the past data, but with the help of artificial intelligence along with the past data, we can see the futuristic parameters also, we can include that also in our forecasting. Similarly, in the maintenance of the processes etc., also we can we can predict the health of the equipment beforehand. Similarly, the health of the human beings also can be predicted beforehand. Various environments, various natural disasters can be, the impact can be mitigated by early warning, early prediction, forecasting of those phenomena. We can reduce, we can mitigate the impact on the human beings or on the economy or on our animals etc. We can reduce the impact of that. So, these are some of the technologies which are going to play a very, very important role in designing our products, processes, systems, services etc. So, let us see means in brief that. So, it is capable of decreasing the production cost because now human interventions are not required, processes are going to be much faster, more accurate, better quality because of real time feedback is given to the processes, and with the help of better analytics beyond the capabilities of human beings, the parameters are analyzed and can be utilized, and then the logistic costs and quality management cost can also be reduced. I can give you one example here. If you see in a steel plant, blast furnace, where the iron ore is converted into steel. So, if this is a furnace, the several input materials are fed into the furnace. So, then these called, because these are natural resources, whether it is a coke, coal and iron ore, and it is not a consistent quality. Whereas, the final steel which we want to produce, we want a very, very good consistent quality steel. So, what we are doing? We in a real time we measure the quality of these parameters, and then we can meter it also. We can change their composition, whether oxygen quantity or whether other ingredients quantities which are required, we can keep on changing in a dynamic manner, in a real time manner, so that I can get a consistent steel quality. So, in this manner I can reduce the consumption of my raw materials and I can get a good consistent quality of steel. So, that is where the production costs are reduced and quality management costs are also reduced, or better quality products can be produced with the help of various sensors, various analytics etc. And then the important thing is digital twins, the implementation of sensors. Sensors and actuators are the you can say building bricks of industry 4.0 or IoT. IoT is small, so in a way we can say that data analytics is one small shell, and then another big shell is I can say that IoT. Another bigger cell is I can say that this cyber physical system, cyber physical system, and beyond that we can see that industry 4.0. So, in a way industry 4.0 required data analytics, IoT, cyber physical system, and then industry 4.0. So, sensors, actuators in IoT, the major components are, as I said, things, and on that these physical things we add sensors, so that in a real time data is collected about the performance, about its working, about its usage etc. So, digital twin, the implementation of sensors connected to the product and processes, capture and store information constantly into the cloud or a server to be processed for smart operations without human intervention and prediction of the performance. So, these are the things which are going to be there in our manufacturing, in our designing of the products as well as in our processes. So, we are going to have smart products, smart plants and smart logistics. Products performing without human intervention. Smart products means we are having so many things, smart mobiles, smart wristwatches, etc., and many more things which we will see in coming time, which does not require human intervention and gives you very good performance. So, a smart product is a data processing object which has several interactive functions. A smart product combines the physical and software interface. The usage of the smart product is interactive and require also some cognitive work by the user. You need some intellectual cognitive activities to fully utilize the smart applications, because you are not performing much, you are only using it. So, whatsoever data, whatsoever information is coming, you should be able to assimilate that. Three features are very important when we talk about the designing of the product and processes. Autonomy. The smart products or smart processes will perform the task without the direct command of the users. They will do these activities independently of its own in an autonomous manner. So, we have to see that what type of input parameters I should give and what type of performance is expected. And we also have to keep in mind the safety of the equipment, safety of the society when we are talking about driverless cars, autonomous vehicles, etc., whether unmanned aerial vehicles or driverless cars. We have to see that we have to give very good development of these products, sensors, etc., so that accidents can be avoided or mishappenings can be avoided, and the performance is as per the expectations of the customers, users. Second important dimension is connectivity, and the connection of the product with the network, with the internet network or with the cyberspace. So, we have to develop, we have to decide where I should keep the sensors and how the data from the sensors is going to the cloud, what is going to the quality of the network, the bandwidth required and other specifications required of the network. Third is the context awareness. We have to collect, we have to perceive, we have to collect the information from the surroundings also. When you are driving on a road without driver, obviously you should be sensitive to the environment. The environmental data should also be collected and machine should have a awareness about the surrounding also. So, in that context we have to see like Intel, their plants are not totally smart plants, do not require any human intervention. Various pressure gauges are there which measure the pressures and other performance parameters of the plant, and based on that all manipulations are carried out so that you get a good quality chips and other electronics components. And this thing is going to happen in our automobile industries also, in our various process industries also, whether it is textile, steel or any industry, and in the service sector also. Now we are finding that many services are handled with the help of cloud, and we are able to do so many transactions and other things without physically visiting that particular facility. So, all these things are changing the landscapes when we are designing the banking services, insurance services or other hospital services, telemedicines and other things. They all are getting transformed with the help of these technologies, whether in the form of data analytics or in the form of Internet of Things, or in this another term which is also used is Industry Internet of Things, IIoT. So, all these technologies, the backbone of these technologies, some kind of a digital twin, cloud, and then artificial intelligence or data analytics or business analytics. So, these are some of the cornerstones of these technologies which helps us in improving or better quality of life with the help of these technologies. So, at the design stage, we now have to keep in mind when we are designing the parts, whether it is designing a television, smart television or air conditioners or home appliances or industrial products, we have to keep in mind these features that now these technologies are going to play a very vital role in improving the performance. Friends, in designing of the product and processes, we have studied a few techniques. In that, value engineering is very important technique which was developed in during the Second World War. The idea here is how to improve the value of the product. Value engineering is not the cost reduction. In cost reduction, we may compromise on the performance or on the functions also, whereas in value engineering we say that how to achieve the same level of functions at a lower cost. So, we are not compromising on the quality, we are not compromising on the functional requirements of the product. So, let us see some of the nitty-gritty, some of the important steps in conducting a value engineering study, and at the end we will learn all the steps with the help of one example also, that is the example of a pencil, for which we are all aware. We understand each and every aspects of usage of the pencil as well as the manufacturing of the pencil. It is such a simple product. So, with the help of that we will understand the various steps of value engineering. So, friends, value engineering is an organized creative cost search technique. We search where the unnecessary cost is incurred. It is an organized technique having the 8 phases. We will study that, which is called value engineering job plan. It is a cost search technique for analyzing the functions. Function is at the core of the technique. We say that product per se is not required. It is only the function which it is fulfilling. For that purpose the product is required. So, whole of the thought process, whole of the approach revolves around the function. What function is required by the customer and how to fulfill that function. Analyzing the function of a product, service or a system. So, we can design the product, we can design the service, we can design the system also with the purpose of achieving the required function. Idea is to achieve the required function at the lowest overall cost. We also use the concept of life cycle costing. Overall cost consistent with all requirements which comprises its values such as performance, quality, reliability and appearance. So, without compromising we should produce the product at a minimum overall cost. So, by achieving all the performance, functions, value with respect to performance, quality, reliability and appearance. Value engineering results in increased use of alternate less expensive material. Actually, this was during Second World War when there was scarcity of materials. So, the value analyst, value engineers tried to find out what alternative materials can be used because there was scarcity, and to their surprise that they found that the alternative materials are much more efficient. They provide the functional requirement at a much lower cost, and that give birth to this stream of value engineering. Once the war was over, these value specialists were deployed in industry to improve the performance of the products and the systems. So, to use the alternate less expensive materials, cheaper designs, weight reduction, new methods of manufacturing etc., to give the same performance, quality and efficiency at a lower cost. Value engineering aims at promotion of value awareness and raising the level of professional competence and technological excellence. Value is a function divided by cost of worth. So, we have to achieve, we have to improve the function and we have to reduce the cost. To improve the value, we have to improve the function and we have to reduce the cost. So, the idea here, the cardinal principle in value engineering is challenge everything, challenge everything. There is a difference between optimal and the best. In optimal, we say that within the given circumstances, within the given condition, what is best. But when you challenge everything, you are not assuming anything, you challenge, you can change everything. So, in that case you get the best solutions. So, value engineering is cost avoidance instead of cost reduction. So, value engineering providing necessary functions and avoiding the unnecessary function. We see that if there is something which is not required by the customer, why to have it in the product. So, first question is why this is there in the product. If there is no function, if there is no answer, why this is there. If there is no answer, let us eliminate it. Then maximizing of value not only achieved by reducing cost, but value can also be enhanced by improving the functions that are desired by the customer at a relatively small increase in cost. As I said, at the productivity stage also, we are saying value is equal to function oblique cost. So, there are 4 ways by which we can increase the value. One is increasing the function and at the same cost. Second is same cost and reducing the function. Third is increasing the function as well as reducing the cost. 4 is a large increase in functional value with small increase in cost. So, in that manner we can do improvement in the value. So, all 4 kind of things are applied in improving the value in value engineering cases. So, the objective is to identify the customer needs. All design steps starts with customer needs, and customer needs are expressed in terms of function, not in terms of product. I will say that if I design a pencil, I will not say that I have to design a pencil, I have to design a product which fulfills a function which is called make mark. The function of the pencil is make mark. So, I want to design a product which achieves this function of make mark, like that. Similarly, a tumbler, idea is to hold liquid or hold material. So, any product which can hold material, hold liquid is a good product. So, we have to see that what is the basic function of a particular product. So, find out the function and their cost. So, in a given product which is there, we will see that what are the functions this product is performing and at what cost these functions are achieved. Then identify the high cost functions, the functions which are having high cost, but its value is less, we identify that, and then we create the alternatives. In the creative phase, we create the alternatives, so that for the high cost low value function, we call it high cost low value function. For high cost low value functions, we create the alternatives. We will see in the examples also, and then select the most valuable alternative for implementation, obviously after thorough analysis. And what are the benefits? High productivity, cost reduction, improved producibility, reduction in lead time, improved parts items, number of items required, bill of material availability, better reliability of the product, better performance of the product, better quality. There is weight reduction. My favorite example here is car. In the last, with the help of value engineering, most of the automobile companies and other companies are having a value engineering department. They keep on working on improving various components and parts for the purpose of weight reduction, etc. I would like to share a very important, very interesting example. If you look at the cost of products, whether it is a refrigerator, air conditioner, or even the cars, 800 cc car or 1000 cc car, in the year 2000 also the rates were almost same as it is today in 2022. How it is possible that whereas there is a 2-fold, 3-fold increase in the cost of steel, there is maybe 5 to 10 times increase in the cost of salaries, etc. Every other input resources has increased from 2 times to 10 times, whereas the cost of the final product is by and large same. I am talking about the same size, same feature kind of a product which was available in 2000 and also available in today in 2022. The major contribution of this goes to value engineering. They keep on working on reducing the weight as well as on finding the alternative materials, alternative designs, so that the product is manufactured with better performance at a lower cost. So, that is the benefit of value engineering we are witnessing in our life, in our personal life also. So, it helps in leading to better quality, improved logistics, better packaging, and improved maintainability. If we look at the qualitative benefits, better cooperation and understanding between individuals and departments, database management, continuous updating, encourage creativity in the organization, widespread tendency to think functions rather than parts. Whole approach, the heart of the value engineering is function. Improved capability to cope with changes. the difference between value engineering and cost reduction. The conventional cost reduction program, if we look at, they are more item oriented, tend to follow past practices, analytics in approach. So, there is not breakthrough changes. Whatever you are doing in that itself, they are trying to do something small changes in that. Convergent ideas, we try to see that ideas are converging. Cost visibility is part wise, not function wise and process wise, and usually individual oriented work. Whereas in case of value engineering, we find the approach is not item oriented, rather it is function oriented. We want to achieve the function. The product is meant to fulfill certain function. Application applies innovative approach rather than following the trends. You don't accept anything which is existing, you challenge everything there. So, exercise maximum creativity, no holes barred. Divergent convergent idea. First we try to diverge, we try to create more and more ideas as diverge as possible, and then we start converging them together to lead to the final answer, final product. Cost visibility is in the form of function, basic functions, primary functions, secondary functions and unnecessary functions. And I try to see the unnecessary cost with the help of identifying the unnecessary functions. And then it is a teamwork approach, it is a multidisciplinary approach, where the team members are from several areas, from the marketing, from the research and development, product development, manufacturing, production, procurement and costing people are also part of this team. And let us see some small definitions. Value, it is the lowest possible cost of a product, service performing a useful and essential function with required equality and reliability. Value is defined as needed performance at minimum cost. So, value is nothing but, we say use in our daily parlance, we use the, what is the value proposition for me? What is the value proposition for me for a particular product or a particular offer? So, what we say, how it is going to perform for me and at what cost I am going to get that. So, that is called value proposition. So, what is the value for me of a given idea, given product, why I should have it. And this value we expect, there are several types, only 3 are listed here. One is use value, what makes it work. Esteem value, what makes it sale, just like you are wearing jewelry, ornaments, it has more esteem value, less use value, whereas turbines, fans, etc., they are having more use value and less esteem value. And then there is exchange value, at what one can trade for it, at what price I can trade for it. And then the second important thing which we have to see, what is the worth of that item for me. The monetary equivalent for every type of resources being expended or expected in order to achieve single function or a group of function together, making up a project designed to satisfy the specific needs of the customer. So, worth is, what is the money equivalent to that? What is the worth of that to me? We say that whenever we do shopping, oh, this is worthwhile. Worthwhile means the cost is more, cost is lesser than the importance to me. So, that is we call it worthwhile. Function, function is what makes an item work or sell. Function is expressed with the help of verb and noun, just like I said, pencil, make, marks. We can take some more examples also. Like I said, switch, break circuit, make circuit, regulator of a fan or any equipment, regulate flow. So, we are explaining that with the help of 2 words only. Why we are explaining with the help of 2 words, why not with the help of a sentence or a phrase? If we are writing a sentence or phrase, it may have different interpretation for different people, but when we use only 2 words, it will have the same interpretation for all the team members. So, that is one of the cardinal principle of value engineering. We define the function with the help of 2 words only, that is verb and noun. So, objective of the value engineering is to make worth to cost as one, though it is not possible, and value index is worth by cost. How many times the worth consumer is getting against the cost? Very important concept here. When should I apply the value engineering? At the initial stage, at the conceptual stage, or at the operational stage. This is the life cycle stages of the product. What happens if you apply at a conceptual at a later stage, the cost of implementation is high and the benefits are also very less. So, because at a operation stage so many changes you need to make, already you have committed something, so many changes you have to make. So, the cost of change is very high and there may be several things which you may not be able to change to get the full advantage of the value engineering. Whereas, if you are applying it at the idea stage or at the conceptual stage itself, then you will find that the implementation of the idea is very easy and there is no constraints in the system, everything can be applied. So, the potential of improvement is very, very high. So, this is the value gap or the improvement possible, much more at net saving potential. Here it is very less, whereas if you apply it at the idea stage itself, the improvement or the potential is very, very high. As I said, it was developed during Second World War. Due to scarcity of raw materials, value analysis teams were formed to search for alternate ways to achieve a given purpose or a function. There are alternate names: value analysis, value engineering, value management, etc. It uses a systematic job plan. The job plan outlines the specific steps, 8 steps are there, to effectively analyze a product or service in order to develop the maximum number of alternatives to achieve the products or service required functions. The phases: orientation phase, information phase, function phase, we will see them in detail in coming slides. Creativity phase, analytical phase, whatever we have created, we analyze that, evaluate the alternatives and then we recommend to the management, recommend to the seniors and then implementation. So, this way 8 steps are involved in the value engineering. Let us see one by one. First step is selection of the product or a project. Which product, which component, which part, which service, which process I should select. What is to be studied? Submit ideas for project. Here also you can try to find out what are the various things, generate the various projects which can be implemented, which can be studied, and out of that evaluate for potential benefit. The projects which are having high potential benefits, that may be selected, where the return on investment is high or time to implement the results is less, or there may be some other benefit. It is a hazardous work where, or it may be creating environmental damages, or it can affect the safety of the worker, something like that. So, that can be selected as a project. Other than economic consideration can be there in selecting of the project. Here in the orientation phase, we are also appointing the team, allocate the resources also, overcome the roadblocks. There may be several roadblocks. People may say that, oh, we are using it for last so many years, why to change it? It is performing very well, why to change it? Or there may be obstacles in the form, we do not have the necessary competency, we do not have the necessary resources to do that. So, we have to create the atmosphere within the organization, so that there is a acceptability of the project, and then set the goals also, what you want to achieve, set the milestones also in between you are going to achieve, and the total project duration in which you want to achieve that. Establish the priorities and approve the project, get the project approval and start it. So, this is part of the orientation phase, where we are preparing the ground for our other systematically taking the project. Then once the project is selected, the important step in every study is collecting the information related to that. Here we collect all types of detailed information and data needed for the project, collect all available data with respect to labor, material, plants and machinery, etc. Reliability of the information should be very high, and so that we should try to collect the information as far as possible from the primary sources where the data is generated, rather than the secondary reports and other things where the data may get distortion. So, we should select the data from the right sources, which is the most authentic source of the data. We should ask the key questions while collecting the data. Who made the specifications drawing and when? how old is this specification, what was the team structure, what were the constraints at that time, was it ever reviewed and revised, if so when, are the specified material easy to get or they are specially made for us like special material and standard material, were alternate materials can be used, is there one supplier for the item. So, some of the questions to explore, collecting information around that. Were complaints ever received regarding the item? What is the history of the item? How many complaints, warranty returns, etc., internal failures, external failures, what type of controls, quality control checks are required. So, around that. Are the cost based on the recent estimate? You may have a costing which is done 5 years back or 2 years back. So, you should have the cost data of the recent periods. Are there any hidden cost? Have we considered everybody who has anything to do with the product, so that each and every aspect, each and every cost is captured? Which aspect of the project in your opinion can be greatly improved? Product may be like cars, etc., or can be. So, there may be several aspects. Which aspect should be considered? There are several types of hidden cost in any system. Certain costs are visible from outside, certain costs are not visible from the outside, like losing a customer is a hidden cost of poor quality, or there may be delays in service, or you are expediting high logistic cost which may not be visible to you. So, these are called hidden cost related to the product. Then the third phase, which is the heart of the value engineering, is function phase. Function definition and analysis is the heart of the value methodology. It is the primary activity that separates value methodology from all other improvement practices. There are several such kind of approaches available. Improving operation research is there, method study is there, and quality circles are there, which helps in improvement. But the unique aspect of value engineering is its function approach, which makes it different from others. The objective is to identify and define function in third phase, function phase. We identify and define the functions, classify functions into basic, secondary and supporting functions, as well as we identify the unnecessary functions, determine functional relationships. We are doing it in. So, define the function with the help of 2 words: electric bulb, produce light; tap, control flow; pencil, make mark; refrigerator, preserve food. So, in that manner any product we can define with the help of 2 words, that is verb and noun. Perform cost worth matrix of each function. What is the cost of achieving that function, and identify the unnecessary cost. Determine value opportunity cost of each function, determine overall value opportunity cost, and determine the overall worth of the project. We will see when we are doing a example of pencil, all these steps we are going to follow very religiously. We are going to follow all these steps there. So, key questions are: what does it do? If we find that there is no purpose of this, we may totally eliminate that. What must it do? So, creating the right approach, right things which is required. What does the function cost now? What is its worth? Is the function basic or secondary? Are there unnecessary functions? So, we try to identify that. So, we classify the functions as basic functions, secondary functions, supporting functions, and unnecessary functions. Like in LCD projector, there may be unnecessary heat created by the bulb. So, that is an unnecessary function, dissipating the heat. All such things, parts, etc., which you are using to dissipate the heat is a unnecessary function. Secondary function may be because of certain design features, or maybe certain secondary requirements of the customer also. Supporting function can also be due to some secondary requirements of the function of the user also. Then, as I said earlier, the end of the function phase is to identify poor value function. To identify poor value functions, the functions which are having high cost, and low value. So, they are called poor value functions. And then in the creativity phase, we generate the alternatives for this poor value functions. By using several idea generation techniques. So, to generate alternative methods for providing the needed functions of high cost design elements and those with high value opportunities indices by creative thinking, brainstorming and even speculation. So, such kind of approaches can be used in the creativity phase. So, key question is what else would accomplish the job required function, what else can be done to achieve the required function. This involves generating a large quantity of ideas. We have seen that we should generate large ideas because in screening and in analysis we found that several ideas are died out and not able to pass the test of scrutiny. So, generate large quantity of ideas for alternate means of accomplishing the basic function. Challenge everything is the cardinal principle. There is always a better method of doing it. These are some tips for creating when our creativity is high. Select the right time of the day when our creativity is very high. State the problem carefully and clearly. If you are not given the problem definition, articulated the problem in a proper manner, people may get different ideas and you may get ideas which are not worthwhile. Organize your approach and avoid generalities. Use idea banks and idea museums also. There are certain ways certain things are already there in archive. Build up your idea resources. Build big ideas from little ones. Set a quota for ideas. Try the input output scheme. Talk it over and use innovative techniques. Use information from only best source. Identify and overcome the roadblocks. Then once the idea is generated, we analyze those ideas in the analytical phase. Evaluate the feasible alternatives through evaluation metrics, rank the alternatives and select the best alternative for the development. Determine techno-economic feasibility of the selected alternatives. So, we have to see that it is technically feasible and economically also it is viable. Key question: will each idea work? Will each perform the basic function? Will it sell? How feasible are selected alternatives? What does each cost? It is from this phase onward that the ideas generated are subjected to screening with function, performance, reliability, etc. The different ideas may be refined, combined, divided, modified, amplified, dropped to arrive at a final set of alternatives which will accomplish the function. Then come the evaluation phase. Put the recommended alternative vis-a-vis cost and benefits before the decision makers in such convincing terms that they will accept the recommendation, to make recommendation for the specific action and to suggest an implementation plan of action. Key question: will the customer needs be satisfied? Will it meet all requirements? Who has to improve it? What are the implementation problems and what are the costs associated with that? Few more questions. What are the savings potential if it works? Which is the least expensive? Will it be relatively difficult or easy to make the changes? Is there time to implement? What are the chances of implementation? Then come the recommendation phase. We recommend our proposal to the top management and we also tell them what are the cost saving, what are the resources required, how it is going to be beneficial for the organization. And the selected alternatives are presented to the top management, bringing out the advantages of recommended study vis-a-vis disadvantages of the existing product system. And then come the implementation phase to assure that approved proposals are quickly and properly translated into actions to achieve the savings of the product improvement that were assured. Various phases in this are implementation phase, audit phase, extension phase. Key question: has the recommendation being fully implemented? What are the problems? What are the savings, advantages? This is the feedback from the implementation basically. How and who will monitor the progress? Who are responsible for implementation within the time preset? This phase meant for translating ideas into actions. Proper planning, execution, review, coordination and control techniques have to be applied for successful implementation and completion of the project within the time and cost parameters. Use of good human relation is essential for implementation. Now, let us come to the example, how to implement this 8 phases with the help of a example pencil. Orientation phase, a selection of the project. Why in a classroom setup, why we have selected pencil as a case study? Because it is a very common item, everyone is familiar with it. Assorted audience from different branches can be there. Product structure and manufacturing process is simple and transparent. Everyone can understand how a pencil is manufactured, and cost visibility is also there. Formation of the team, all the participants of the course of the program can be a participants, or we can form teams of 5 to 7 students participants in that. Now, we collect the information, the second phase of our value engineering job plan. In a pencil, let us, for the purpose of this, we say that pencil is of 1 rupee or 100% cost if we consider. Out of that 15% cost or 15 paisa is of graphite, 65% cost is of wood, 10% cost is of paint, 5% cost is of adhesive, and 5% cost is of making. In a total cost, this is the breakup of the cost approximately we can consider. Now, let us see the functions of these materials which are used of each part and process. Let us see the functions of this. The graphite is used for, which we call it lead pencil, lead popularly because of its black color. The purpose of the function of the graphite is make marks. Function A. Wood is to protect the lead, graphite which we are using to protect the lead and provide the grip also. With the help of wood, we get the grip also while writing, and lead is also, because it is fragile, it is also protected in the process. The paint, it provides the smoothness, it is not injuring our finger, and it provides the smoothness, and also it protects the wood also. If wood get wet, etc., it may damage it also, spoil the pencil also. So, it provides the protect the wood as well as it provides the smoothness, so that we can easily grip it. We can also write another function, provide grip also. Adhesive, provide bonding. Adhesive is used, the pencil, the wooden part is made in 2 halves, and by keeping the lead, circular lead in between, with the help of adhesive, it is bonded together. Then the marking is, there is something written on that, HB, 2H, 3H, then the manufacturer name and other things are written on that. So, that is to convey the message. This pencil is made by a particular company and it is of hardness, and it is HB or 2H or a 4H, which is required for different application, or it may be 2B also, or like that also. So, it gives you the message, convey message. So, this is our function phase, we are able to define the function. Now, next step is to compare the function, which function is the most important function out of the given 7 functions we have identified: A, B, C, D, E, F, G and G. So, 7 functions we have identified here. So, now we compare this with the help of a pair comparison technique to see that which function is most important. So, here in this folks, I compare A with B, whether make marks is more important or my function B. B function is protect lead. For a pencil, make mark is more important or protect wood is more important. So, obviously, make mark is more important. So, like this I compare in a pairwise manner, and then I will count the score. Wherever A is coming, I count the score: 3 plus 3 6 plus 3 9 12 15 and 7. There is some small mistake here. So, let us make this as A2, so that the score is 17, and then for B let us count it 2 4 6 7 3 10. For C the score is 1 plus 2 3, wherever C is coming I am counting that. For D the score is 2, for E the score is 2 4 plus 3 7, for F the score is 3 plus 2 5 plus 3 6 8 and 3 11, and for G my score is 0, nowhere G is coming. Okay. So, like this. Now, we are finding that G has got a score of 0, whereas it is also part of the pencil requirement. So, we add 1, we moderate the score, this is called raw score, and then we moderate these scores by adding 1 to each of them. So, 0 is becoming 1, 11 is becoming 12, 7 is becoming 8, 2 is becoming 3, 3 is becoming 4, 10, 11 and 17 is becoming 18. And then total is 57, and then we can convert them into percentage. So, this is how we have converted the various functions the product is going to perform, its relative importance. So, this is the relative importance on a 100-point scale. Now, we are having a relative cost of the various parts of the pencil and the relative importance of the various functions, and from this we will develop the function cost matrix. We will develop the function cost matrix, function value cost matrix. Function A, make marks, the value importance is 31% and it is coming basically from the graphite, and the cost of the graphite is 15%. Then function B, protect lead, its importance is 20%, but its cost is 30. Total cost of the wood is 65, which is broken into two functions, protect lead 30% and provide grip 35%. Provide grip has a importance of only 7%. Provide smoothness 5% is the importance, 5% is the cost. Protect wood 14% is the importance and 5% is the paint, cost is 5%. Provide bonding, very important, 21% is the importance and 5% is the cost. Convey message, 2% is the importance and 5% is the cost. From this we found that these two functions are poor value function. The value is 20% where the cost is 30%, value importance is 7%, the cost is 35%. So, these become the candidate for our next phase, that is the creativity phase. And so in the creativity phase we generate the ideas for alternative materials, alternative things for the achieving these two functions, that is providing grip and protecting the lead. And you will find in the market the various alternatives which are coming for the pencil. There is no change in the graphite, but all the alternatives, whether it is a clutch pencil, whether it is a magic pencil or any types of pencil, the change is with respect to achieving these two functions, that is grip, alternative to wood with the help of several other ways that are the you will find in the market. So, in this phase ideas are generated to achieve the function, that is protect lead and provide grip. Then we generate the alternatives, and let us say we have generated the 5 alternatives. We have generated the 5 alternatives here in the creativity phase. One is the clutch pencil, second is the magic pencil. Magic pencil is the lead is of the diameter of around 10 mm, so that you get the grip. Then synthetic pencil, where rather than wood we use the synthetic material. Then there is a bonsai pencil, where small units are there which you can keep on inserting from the back, you use it, consume it and insert, there is no sharpening required, and plastic barrel is there, and then it is a wood pencil, the existing pencil. So, 5 alternatives are created, and now we are analyzing, and from the analysis we are able to generate these 5 alternatives. Now, evaluate these 5 alternatives to see that which one is the best. And for evaluation we use the multi criteria. Multi criteria can be cost, it can be user convenience or other parameter, we will see in the next slide. And then we decide the their weightages, how important a particular criteria is with me by using the pair comparison, just like we compare the functions we can use that, and then we will evaluate the alternative and select the best alternative. So, this is my multi criteria evaluation matrix. Let us say 50% importance I am giving to cost, 30% importance I am giving to grip and 20% importance I am giving to ease of sharpening. And then these are the 5 alternatives which I am having. E is our existing traditional pencil of wood. A is it is written here. A is our clutch pencil. B is our magic pencil, C is synthetic pencil, bonsai, and you will find clutch pencil and bonsai do not require any sharpening. So, from that perspective you will find A and D are very high on the score. A and D are very high on the score because they do not require any sharpening. On the other hand, from the cost perspective, from the life cycle cost perspective, you are finding that clutch pencil is very less expensive life cycle. The pencil may be costing you 50 rupees or 100 rupees, but the cost of the lead is very less. So, you can keep on refilling that cost and you can use it for a longer period also. So, the cost life cycle costing is very less for alternative A, it is even less for B also, magic pencil also, and because grip is good. So, similarly, we can compare this, and based on this comparison we found that clutch pencil is the most economical, better based on these three criteria, and I can select that. And then this is a classroom kind of exercise, then you can implement that. So, giving you an overview as a concluding marks, value management encompasses the following areas: value engineering, life cycle costing, project management also, because we have to implement also, creativity, creative problem solving, teamwork, and management of change. Change is also required. So, we have to keep in mind when we are taking a value engineering project, we should focus on life cycle costing, project management, and management of change. Management of change may have several human dimensions also along with the technological dimension. So, in this session we have talked about two important aspects. One is Industry 4.0 and its application in product design and process design, and second important topic which we have covered is value engineering, its applications in product design. And value engineering is based on the function approach. We see the functions of the product, and based on the functions we try to generate the alternatives by identifying the poor value function which is having high cost and low importance. So, based on that we develop the alternative and select the best alternative and implement that. So, thank you so much.
Hi, my name is Gillette Sam and I teach sociology at IIT Kanpur. One of the things you must have noticed if you read or if you talk to people around you is that they often refer to something called globalization, or they often say we live in a global world. What does this mean? Today I'll tell you about how to think about globalization or interpret the word global in a sociological manner. When sociologists refer to globalization, they refer to three things. The first is that that it involves transplanetary processes, which means that something is going on across multiple borders, right? The second is that it involves heightened liquidity and interconnected flows. Now, by liquidity, and this is a term that was coined by the sociologist Zygmunt Bauman, we refer to the increasing interconnectedness of things across the globe, but we also refer to increasing instability across the world, which means that potentially something that is occurring many kilometers away from you actually influences the place that you live in. So, if there is a natural disaster happening in one part of the world, maybe that causes people to migrate from that area and they come and settle where you stay. So, that is what we mean by liquidity. And of course, when we are talking about liquidity, we are talking about things that are really moving from one place to the other. Now, the third aspect, and this is something that you may not conventionally come across in the way people use globalization, is that of structures. So, let's take an example. Supposing I, as an Indian citizen, wish to visit a foreign country. Let's say I want to go to South Africa. Can I just pick up my bags and hop on the next plane and go to South Africa? Any logical person is going to say, no, wait, you need to have documents such as your passport or visa. Now, this passport or this visa is a representation of the larger structure that governs how people move across borders. So, we have things like border control, national security agencies that consider what kind of people are going to move from one place to the other. Correct? So, when we think about globalization, an average person typically tends to think about things moving or people moving from place to place. As sociologists, we also consider that there are structures that facilitate or direct this movement across multiple borders.